So this is our 2012 free response number 5, part B. And what we are asked to do now is find the second derivative, d squared b dt squared. We're supposed to find it in terms of b. And we need to pay attention to that it has to be in terms of b. And then we're supposed to use that second derivative to explain why the graph of b cannot be this graph. We don't have to come up with what graph it can be, but it can't be this, and we need to say why. That's what it says. Cannot resemble the following graph. Explain why. So let's do the first bit first. It says find the second derivative. So what we know is that the first derivative is what is given, db dt, and it's given in terms of b, meaning that I don't know what dB dt is unless I know what b is. So I would be able to plug in b, then I'd get dB dt as we did in part A. Now I'm asked to find d squared b dt. What I've found to be sort of easiest with this is let's distribute this 1/5 out first. And that will just make the derivative a little bit easier to see. We won't have to do a product rule or anything like that. So our dB dt, I'm just rewriting it. I'm not doing a derivative yet. 1/5 of 100 is 20. And then I have my minus, and I distribute the 1/5 and get 1/5 b. Now that's still just dB dt. Now I want the derivative, d squared b dt squared. So I'm taking the derivative of that dB dt. That derivative is, the derivative of 20 will be 0, and the derivative of negative 1/5 b, this looks like maybe it should be a product rule, but it's not, because the thing that is multiplied times the b is a constant. Since that's a constant, I can just bring it down and say this is negative 1/5, and then I just have to say what the derivative of b is. Well, I don't know what the derivative of b is, but let's just say it's b prime. I could also call it dB dt. In fact, I know what dB dt is. So this b prime right here is the same as this dB dt, which is this. So I can replace the b prime with this whole expression, all of this. So I'm going to have another 1/5 times 100 minus b. So then this is the substitution that I've made for my b prime, because dB dt equals this expression. Now I can just simplify that by multiplying the two 1/5s together. I get negative 1/25 times 100 minus b, and I can probably just leave it like that. Now I've done the first part of this question. I have found d squared b dt squared in terms of b. It is in fact, here's my d squared b dt squared. It's in terms of b because it's got a b in it. Now my next job is to explain why the graph cannot resemble this graph. So there's something about that second derivative that this graph cannot match. So I need to think about, what does second derivative tell me about a graph? Second derivative tells me about concavity. So what I would look for here is, this graph has got a concave up part and it's got a concave down part. And they're split in here somewhere, but I don't know where. But I do know that I could estimate where the b is, that it splits concave up to concave down. But the key to it seems to be concavity, because it's asking me about second derivative. So let's look at the second derivative that we have here in terms of b and see if I can say anything about the concavity. Well, what I might want to analyze is, where is it positive and where is it negative? So I can look at these two factors, the negative 1/25 and the 100 minus b, and see if I can say something about when they're positive, when they're negative. Negative 1/25 is always negative no matter what I do. Let's look at this 100 minus b. Well, the weight of the bird is always less than 100. That makes sense, because the adult weight of the bird, we can infer from the context. And when it says proportional to the difference between its adult weight and its current weight, that must be the adult weight, 100. But I can just see that on the graph here. The bird never weighs more than 100 grams. That's the weight right there. So since b is always less than 100, that means 100 minus b is always positive. So that means that our d squared b dt squared is always less than 0. So we can say that d squared b dt squared is less than 0. That means the graph of b the b graph, let's put it this way, the b graph is always concave down. But this graph is sometimes concave down and sometimes it's concave up. So this graph is, but the given graph has, let's put it this way, has sections, has one section really, that are concave up. Therefore, it cannot be that graph. And that's, now we've finished part B. So we've determined dB/dt in terms of B, it's here, and then we said because that second derivative is always negative, this graph cannot be the graph of B because this graph has a concave up part. And that's part B.